SQL is a language that has been developed like in the 70s, and it looks old for developers. I don't know how many developers are you? Like, okay, so it actually looks quite long to write and has some downsides. For example, type safety. You don't know. You have to declare what you are expecting back, and in case you expect something but you receive something different, which is possible, then you have a bug, and you find about this bug only at execution time, which is something that you don't want on the blockchain, because once you upload a contract, it's that, and it's there forever unless you upgrade. So this is a big downside of SQL languages, and in theory, relational algebra does not allows nulls value, and null values in SQL creates some degrees of complexity. So we took all these feedbacks and we rewrote a language that interprets into SQL, but adds some security feature. For example, is typed and is declarative, so you have to say what you're getting back, and in case does not match what the compiler says, you get an error at compilation time, so while you develop. And we do not allow null values. All of these and many other things we changed, and this ended up being a 7 times more compact code. So in SQL you have very long lines of code, and it's very complex sometimes to read. We instead created this language, and it's 7 times more compact. So we have some basic types. Essentially are Boolean, integer, text, byte array, JSON, that are the basic one, and is what you expect usually to use in your daily life. And now we are launching decimal, which is kind of unique of a thing in the blockchain world, because everybody is using integer, but we can actually allow decimal with exponent mantissa, so with some basic method numerical calculus that you study in university. And this is, of course, is kind of easy, like it's something that everybody studies in university, but it's difficult to implement it on the blockchain because of current limitation. But by using SQL, it becomes much more easier. Then we have a unit, which is the representation of a row in the database, and null. Null cannot, of course, cannot be stored in the database because it's against the principles that we set before. And we also have aliases such as public key, name, timestamp, and TOID. So you can replace if you don't want, if you have a public key, you can just write public key, and we automatically interfere that is a byte array. We have more complex types also, which is, for example, class, which is what in SQL is a table. So table is class, and inside it has different parameters. They can have different types, and a type can be nullable. So it cannot be stored as a null value, but if you expect something from the database and this returns empty, so there is no line, for example, this is a nullable. So you might declare this as a thing that might not exist, and then cast it out to verify if actually there is something in there. We have tuples, list, set, maps, ranges, like in Kotlin and in other languages, and GTX value, which is a special value that we use to transfer data from within the transaction and the engine that execute the modules. We support the basic operation, create, read, update, delete, totally on the blockchain, and this can be, of course, used within within a transaction. And this is essentially how it works. This is how you declare a table. So, for example, we have class bet is essentially creating a table called bet, and the column that he has is a sport event, so we are linking to the table sports event, which is the one on the right. We link to player, so is the second column, and then you can say who is the winner, for example. So I think in this example we have Drago versus Creed. You can see who will win, you can bet on that, and the amount you want to bet. So it actually looks quite neat, but there are three relations in here. And of course we support index, which is a very interesting feature for blockchain, because right now the problem of blockchains is that there are big databases that store all the information, but we cannot really look for them and do operation on them. It's very complex. Yeah, and of course we support a unique key with a keyword key, for example, name. The sport event must be, the name of the sports event must be unique. This is, in the middle is, you see how we create a sports event. Like, so when you insert an item into the table, and it's just by create, you call the name of the table sport event, and you insert the parameter. So the sports event is only one field, which is name. We pass a string, which is Drago versus Creed. Of course, after you created something, it's very nice to read them. So to get this data out of the database. And to do that, we use this syntax. So you are forced to say from where you want to get a result. So it can be, for example, sports event. Then we have this cardinality, this at operator, that acts as what I'm expecting back, how many things I'm expecting back. So if it's only one at, is I'm expecting one row, basically one object out of type class. If it's with a question mark, it's is a record that might not exist in the table. If it's star, can be 0 or n, and at plus is 1 or n. So we don't have null in there. And we have a where clause, so we can say here we have it's not this example. Okay, we have, for example, in one column called age. We want to filter by age greater or equal 12. This is how we do. And lastly, we have to say what we want to get back. By default, we get a unit, so it's just a reference to the record on the database. But of course, we can get a single column, and we can also sort them with keywords. And yeah, this is an example. Okay, you can see only half of it. Here, we are selecting a bet with the public key of the player. So for example, if I want to get all the bets of a specific player, I insert the public key and I say go in the class bet, select one or more from all the results from 1 to n, where player public key is the same as the one I'm inserting. So actually also interesting to see that we actually don't have to join the tables like in a normal SQL, but we shrink this part of the code and we do it ourselves. So you just do player.public key and this automatically is representing a join. And then we want to get back the amount of this bet, so we can just select that. We have updates. Updates is actually a mix, is essentially a select with an extra part, which is this parenthesis at the end, where that allows you to set the new value in a specific column. And delete also is pretty easy. It's just a select with in front the keyword delete, and so you can delete it. Bear in mind that when you delete something from the blockchain, you are not deleting it like forever. Like you don't have like in your current state, you don't have this record anymore. But it's written in history that this record existed in the past, has been deleted, and now is not in the current state. So we are not missing information. We have statements, so once you have this CRUD operation, you also need to tell through the blockchain what you want to do. So to do that, you use operation. Operation are like are called within the transaction. So when I make a transaction, I say the name of the operation I want to call, I say the parameters I want to specify in the call, similar to other blockchains. Then I send it to the node mines it, and then calls the operation on the SQL database. We also have functions, which it's pretty similar, but cannot be called by a transaction. So, for example, if you want to simplify your code, you want to put a function outside of the operation, so you don't want to have a huge spaghetti code, you can do that with functions. This is the class, you already saw that. It's essentially creating a table, and we have index and keys. And an important thing, we also have a keyword which is mutable. Like usually in the blockchain, you don't want to change things. You just want to append information. So it's like, for example, in Bitcoin, I had this money, then I transferred this much to this person and this much to another person, and then I did that, and so on and so on and so. You don't really want to change the amount that you have, for example. So by default, parameters are supposed not to be mutable. But for example, amount, which is something that, for example, in Ethereum you want to do it to update amount, you can do it by declaring this column with a keyword mutable. Record is essentially a class that does not exist in the database. So it's an object that is not recorded in the database, but can be used for simplified code execution, essentially. Yeah, query, we already saw that. Essentially, is for example, this is a select, and the name of the function that makes the query is characterized by the keyword query in front. And what does it do is the client can call, can ask for a query to the node, and the node can respond with this set of instructions that is specified in here. The operation similar is like writing a function, but the operation asset can be called by the blockchain, by a transaction through the blockchain. And the function, it looks exactly the same, but cannot be called through a transaction. And interesting thing, we have this actually very modular, we have a lot of flexibility with this language, so an important thing is that you want to require a person that sign a particular transaction, so you want to see something that happened on the blockchain in the SQL code. So we have this keyword is signer that allows you to check if the person that makes the transaction actually signed this the person that is claimed to be in the operation is actually the one that signed the transaction. So you want to match that what is said at the database level, SQL level, match with the transaction. And that's how you do. You can also, for example, append a message so you know what's going wrong, stuff like that. And yeah, this is pretty much it. If this thing tickle your curiosity and you want to like check it out, how it works, is actually quite easy. We have a Docker image that you can download on our website chrome.com, and it's really like 5 minutes. It takes longer to download Docker than to set up all the rest. Of course, it's possible to run it on terminal, like the single node or or like a networker node. Or we also have an Eclipse plugin that helps you to develop. So it's like essentially like a normal language, what you would expect from a normal language, that helps you and tells there is a mistake here, you forgot the semicolon there, and yeah, so we have the Eclipse plugin. The way we want to show this blockchain, because essentially, okay, we are here saying we have a high scalability, we can provide security, it's very easy to code, but yeah, where are the proof? The use case we targeted is a game, so now we are developing several games, we already had some made, and gaming is interesting because it requires is an economy within the game, so there is always people that wants to win and lose, and it's characterized by a sort of economy. And you want to have time sensitivity, so you don't want to like make a command on the game and wait 10 minutes for it to be executed. You want to have something within the second or very close to that, and yeah, and it solves some problems, for example, cheating, and removes the middleman, which is something that I would say the blockchain is on about. So, for example, you can play poker without having a person taking a cut for your earnings, and stuff like that. And also, you can be sure that nobody will ever steal your asset. So, for example, like Vitaly Buterin was complaining that he lost an asset because the gaming company deleted it, essentially. Having a game decentralized, this cannot happen, and we cannot even prevent you to sell this asset around. Yeah. So yeah, we also have a demo with tic-tac-toe in our Bitbucket. So if you want to check some very easy application, you can check it out. It's quite easy. We actually coded it in 2 hours in a workshop in New York, and people were able to catch up with the language and code it. So it was quite interesting. Yeah, that's it.